All right, so first of all, I do have my earbuds in. It's just for the microphone. My microphone is not working on my laptop. So anyway, I can hear you, even though I have my earbuds in. Um, Also, if y'all are coming to this, you do not need to take notes and submit them to me. I mean, you probably want to take notes, but you don't send them to me. I already have your name when you leave. I'll just make sure I have your name recorded and that you don't have to send the notes. That's just for those that are not here. And then also, if you're not here, speaking of those people, and to y'all too, there are documents online that have all of exams 1, all of exams 2, like for the past decade. So if you're just practicing over the next, 12 hours or whatever, however many hours we have until the exam, not 12, 8, 20 hours-ish. Anyway, however many hours we have, you can just download that document. And if you're taking notes from the video, you can use that document if you want. Just take the notes on your tablet on the exam file, and then submit that to me. Is that clear? Well, it doesn't matter to y'all. But anyway, those files are online. If y'all would like, I can go through all of the free response. Is that something that y'all would like for me to do? Okay, I think it's probably good. If you get lost or if I'm going too fast, then please just raise your hand and stop me, okay? I'm sort of expecting that you've already practiced these free response a little bit and that you sort of know what's going on. So on this first one, and again, yours will be just like this. The only difference is that the number will change and this graph might change. But otherwise, it's exactly the same. I don't even change the words. I mean, unless I change the graph. I change what the graph is called. Okay? The first one, so first of all, we realize that if it goes up and goes down again, that the velocity at the top is equal to 0, and then the time to go up is equal to the time to go down. Right, so for part A, I can find the time that the ball is in the air by saying V top is equal to V naught plus A times T top. I know V top, that's 0. V naught is 40 meters per second. A is 10, and T top, I don't know, but I can solve that for T top, and I find that that's equal to 4 seconds. All right, for every second, the velocity decreases by 10 meters per second, 10 meters per second, that's what the acceleration means. And so it takes 4 seconds to stop. That means that the total time is going to be twice that, or 8 seconds. So the first answer is 8 seconds. The next question just asks me what is the y height. And so I say that y is equal to v naught t plus 1/2 at squared. That's equal to, it was 40, right? The tricky part here is using the right time. You have 2 times, you have 4 seconds, and you have 8 seconds floating around. If you put in 8 seconds, by the way, you're going to get an answer of 0, because that's where it is at 8 seconds, right? It's come back down to the bottom. And then that would clue you in that, hey, the answer is not 0, so I need to go and use 4 seconds. That's the time at the top. Minus 5, that's just half of -10. I'm just trying to save time. Times 4 squared, and that's 160 minus 80, that's 80 meters. Okay? And then I want to know the velocity of the ball at 2 seconds for C. I just use that parametric equation, much like I did in part B. V is equal to V naught plus AT. That's equal to 40 minus 10 times T was given. That's 2 seconds. That's equal to 20 meters per second. So that's the answer there. I like to draw circles. I won't count off, but it makes my life a lot easier for grading if I see your answer really clear. So draw a square or box or whatever around it. And then finally, to draw the graph, the V versus T graph looks like that. If I asked you the Y versus T graph, it'll look like that. Okay? That's the first question. Look, that's 4 questions, and you know exactly how to do them. They're not that hard, right? Those aren't hard? No. Just practice them a couple times. Make sure you can do them without any help, and you'll be golden. This next one is a little more difficult. It's just the algebra is more difficult. This is really an algebra exercise. Let's just write down the things we know. X is equal to 300 meters. T is equal to 20 seconds. I'm going to be a little loose with my sig figs here. And then also V final is equal to 0. I know that because it says it's slowing down to a stop. And then I want to know its V naught and the acceleration. I like to write both equations side by side, and I'm going to go ahead and put in numbers. Okay, so V equals V naught plus AT. 0 equals V naught plus A times 20. And then the second one is 300. That's X equals V naught times 20 plus 1/2 of A 20 squared. Now I have two equations. Each of them have two unknowns, and I have to solve that system. You have to do this on exam 2, by the way, as well. Just solve a system of two equations. The first one to solve would be this one on the left. It's simpler. So I say V naught is equal to negative 20A. Then I can take this and I can plug it in for V naught right here. So I get 300 equals negative 20A times 20 plus 1/2 A 20 squared. And now notice I have an equation with just one unknown. I can solve that. That's very easy. 300 equals negative 400A plus 200A. Write out each step, okay? It will help you from making mistakes. If you try to skip steps, you're going to make mathematical errors. 300 equals negative 200A, so A is equal to negative 300 over 200, or negative 3/2 meters per second squared. Or I could take negative 1.5. Either one of those would be correct. Now that I know A, it's really easy to find V naught. I just say minus 20 times negative 3/2, because I know now what the acceleration is. So that's 10 times 3, that's 30 meters per second. All right, so those are the answers there. Is that cool? A little bit harder. The math is a little harder. But again, exactly the same question. Just the numbers are going to change. I copied and pasted the whole thing. And then finally, this one could change a little more substantially, because if I change this to a position versus time graph, it changes what I ask. So you could have a velocity versus time graph, in which case I'm going to ask the instantaneous acceleration, the average velocity, or I might ask the distance traveled. I'll do an example of that here. The other alternative is I give you a position versus time graph. That gives you, I can find the velocity or the average velocity on this question. There are other questions I could ask, but on this question, that is what I would ask. Let's do this one. The instantaneous acceleration at t equal 1 second. Instantaneous means I'm going to find the slope of the tangent line at that time. In this case, it's going to be just the line that is right there. I find the rise over the run. The rise goes from 0 to 2, so it's 2. The run goes from 0 to 2, so it's also 2. And so the rise over run for A is 2 divided by 2, or positive 1 meters per second squared. Watch your sign, okay? If it's a positive slope, then it needs to be positive. If it's negative, make sure you get that negative. So if it was this direction, that would be a negative answer. If you had negative, or if you had a positive where it was supposed to be negative, and it was the right answer, I would probably give you half credit, but you would only get half credit. Y'all know that, right? On the free response, you can get full credit if it's exactly right. If you have the answer wrong, but you've done most of the work right, you'll get half credit. And then if you don't really understand it, or you've made several major errors, that would be no credit at all. Full, half, or all. But what are we going to get? Full, all credit. Yes, that's what we want. 100%, especially on the free response, because you have it beforehand. 100% on that. All right, and then the average velocity. If you read those words, average velocity, you're just picking 2 points and finding the slope of the line between them. So between t equal 1 and 5 seconds, let me change my color here. From t equal 1 to 5 seconds, that would be finding the slope of that line. The rise is negative 1. The run is 5 minus 1, or 4. So B, the average velocity, would be equal to negative 1/4 meters per second. Okay? Alternatively, I could also ask you the area, or excuse me, the distance traveled. If I ask you that, what you need to do is just say I want to know the distance traveled between, say, 2 and 5 seconds. I would find the area under that graph. In this case, this graph was linear, like every portion of it was linear, But there are some examples in the past exams where I have a curved line. I would take a look at those. That requires you to find if you're doing instantaneous anyway, finding the tangent line, okay? We can look at that if we need to. Let's go on and do this. Oh, that was it. Okay, yes, so that's the free response. All right, what other questions do y'all have? Yeah, Trish? Yeah, so you need to know all of your metric conversions. You need to know that 1 meter, I don't like this color, sorry, let me go to a different. That 1 meter is equal to 100 centimeters. That 1 meter or kilograms or whatever it is, that 1 meter is equal to 1,000 millimeters. By the way, the conversion factor here is 10 to the minus 2, 10 to the minus 3. 1 meter is equal to 10 to the 6th micrometers. That's what I told you in class, but in practice, at least right now, we haven't really gotten to using micrometers that often. So you're going to know centimeters or millimeters, or, for example, also kilometers. 1 kilometer is equal to 1,000 meters. That's 10 to the 3rd. That's the conversion factor. I think that's it, really, just those 3, centimeters, millimeters, and kilo, centimilli and kilo. Is that right? Yeah, we'll use the other metric conversion factors in later exams, but for now, that's really all you need to know. I'm pretty sure that's right. If something pops up on the exam, you ask me. It's like, hey, you told me micro wasn't going to be on this exam, and I'll tell the whole class, okay? I'm pretty sure those are the only 3 you needed, though. What else? So, yeah, let me erase all this. I didn't do it because if I wanted to find the area between 2 and 5, what I would do, looking for the area from here to here, because that's kind of an irregular shape, what I would do is I would recognize that each square is 0.5 meters. Look at this square up here. I have 1 on this side and 0.5 on that side, so each square represents 0.5 area. Y'all follow me? And then you can just go and count the squares. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15 full squares. This one and this one add up to make 16 squares. Do y'all see how I did that? This one is a little more than half. This one is a little bit less than half. So that's a full square. That's 16. I'm at 16. And then likewise, I can add these 2 squares. That would give me 17. And then I could add this square to this square, and that would give me 18. So I'd have 18 squares. Since each one is equal to half a meter, the answer would be 9 meters. That's probably the easiest way. I get that the way I added those squares is not exactly right. I just sort of did an estimation. There is a more accurate way you could do that, where you'd break it into, a rectangle and 3 triangles and a square. But I wouldn't expect you to do that. I would give you a simpler shape. So what I'm saying there is that there is a range of answers that I will accept, okay, that are around 9 meters. There's another example. Let me pull it up. I was working it with a student earlier. Maybe it wasn't on the free response. I don't remember. You know, if you know the free response really well, you will find, oh, shoot, no, I guess it wasn't in a free response. You will find that that it helps you in the multiple choice as well. Where is that problem? I can't find it. Anyway, there was a problem with a graph that was curved. Well, we can just do this one. This is not the one I was looking for. But for example, if I wanted to know the distance traveled, say between 0 and 30 seconds, I could realize that each square is 10 times 10, that's 100. So I'd have 1, 2, 3, 4, 5, 6. 6.5 squares. That's 6.5 squares times 100. That would be 6,500 meters. That's the distance traveled. You see how I did that? Just counted the squares. Figure out how much each square is worth. What is the area of each square? Is that clear? Okay. Probably going to have to do that on the free response or on the multiple choice tomorrow. Tomorrow? Tomorrow's the exam, right? Y'all ready? You feel ready for it? Fortunately, if you were prepared for the quiz, right, that carries over into the exam. It's really just chapter 2, which chapter 2 is not an easy chapter. All right, what else y'all want to look at? Which one? Which number? Fall 21, question 14. All right, 21, fall 21. Number 14. This one right here? Oh yeah, these are hard, okay? First of all, when you're doing these, look at each statement. Some of the statements you might be uncertain about. Is that true or not true? And if that's the case, just write a little question mark next to it and look at the others. Because others, you'll say, oh, that's definitely not true. And then you can cross it out, and then you can go and look at the options and get rid of the options that don't include that one, okay, or do include it, whatever is appropriate. That's just a good test-taking skill. Also on these problems, make sure that you identify what is on the y-axis, because that's really important. The slope of a v versus t graph is the acceleration. The slope of an x versus t graph is the velocity, okay? And then you just go for each one. Here the slope has a negative acceleration at point A. The slope of a v versus t graph is the acceleration. Is this slope positive or negative at point A? It's positive, right. So that slope right there is positive, so 1 is definitely not right. I can get rid of that one, that one. The object has an increasing speed at point C. Right here. Is the speed increasing? No, it's actually, the graph as you proceed in time left to right, that graph is decreasing. The speed is actually going down. I'm not looking at the slope there, although the slope is negative, but I'm not looking at the slope. I'm looking instead just at the graph, that it's going from 4 point something meters per second to something that's smaller than that. Just looking at the numbers. So it does not have an increasing speed. So that doesn't help me out on any of those. This object has 0 acceleration at point B. That is true, right? Because it has 0 slope, and it's a v versus t graph. So 3 is correct. I'll put that there. That means that the answer has to be D. I don't really need to go any farther, but I can. The object is traveling its fastest at point B. That's true. Just looking at the y-axis, it's going 8 meters per second. That's the fastest it ever goes. And then the object is traveling in the same directions at point D and E. That is not true. I know just from my options it's not, but it has a positive velocity here, and it has a negative velocity there. Look, those questions, you're definitely going to have at least one of those where I have a graph and I have you several questions for you to ask, but they're varied. Right, so like you can change the graph, you can change the statements. There are many different iterations of that question. And the best way to prepare for it, I believe, is just to go work those past iterations. I don't have an infinite number of iterations in my mind, but we can come up with new things. But if you can do all the ones and understand all the ones that we've done already, you're probably pretty well prepared. Some of you are very fastidious, and I give you these copies of exams, and you work them a gazillion times. And that's great, it prepares you, but it also is a bit of a handicap, because you think you know the questions so well, but you might have just memorized a lot of them. So as you're reading the questions, if you're that student, just be really careful that you're reading the question and not interchanging it with a question that you have in your mind already, that you've seen a gazillion times. Okay? Just be careful. Just a caution to you. I've had students do that in the past. All right, what else, y'all? Yeah. Let's see if I can find one. Because that was velocity versus time. Like this one right here. This one's gonna be a little simpler. This is fall 21 free response. Fall 21. I have a position versus time graph. I'm always going to ask you the instantaneous whatever at t equal 1.75, and it's always just going to be the slope. I'll just find the slope of that. At that point, the rise is -1. The run is 1 to 3. That's 2. So for part A, it's -1/2 meters per second. That's it. I'm not doing a formula. I'm not doing a calculation. I'm not using 1.75 in some calculation. I'm just taking the rise over the run. And then the average velocity from 3 to 5. That's from there to there. I like to draw a line. I'm just looking for the slope of that line now. So that's a rise of -3, a run of 2. So it's -3/2 meters per second. Yeah. See, not hard. These questions aren't hard. If you don't know how to do them, I mean, they're going to be hard. That's true for anything, right? And look, you will not know if you know how to do them unless you try it on your own. If you just watch me do it all the time and then you try to come into the exam, you're probably not going to do very well. But if you try it on your own and you make a mistake at first and then you correct yourself and then you try it again and you make another mistake but then you correct that, like that's when you're really going to learn this. Alrighty? What else we got, y'all? Oh yeah, those are hard, huh? So you will obviously have a question where I give you a graph that looks like that, or something like that, and ask you what is the sign of the acceleration. There are two questions you want to ask. You want to ask, is the thing speeding up or slowing down? In this case, it's slowing down. I know that it's slowing because it starts with a big slope and it ends with a smaller slope, right? It gets less steep. And then also, is it positive or negative velocity? That has a positive slope, so it has a positive velocity. If it's slowing, that means that the acceleration is in the opposite direction. This means A is opposite V. And since V is positive, that means I have a negative acceleration. Okay, let me show you a similar example of X versus T. What do it look like? Shoot. Negative, like that. See, that would be a positive acceleration because it starts with a big velocity and gets slower. It's slowing down. It has negative velocity, so it's positive acceleration. Like a student, I've never seen this before, but a student, I like this. I'm not sure that it will always work, but I don't know that I like it that much. But I'm going to show y'all anyway that if I have a graph that looks like a smiley face, that's positive acceleration. You see how this is half of a smiley face? That's from calculus. And if I have a graph that looks like a frowny face, that's negative acceleration. You see how this is part of a frowny face? Like if it's concave up, it's positive. If it's concave down, it's negative. Okay? But on those questions, that is masking a misunderstanding or not like a not understanding what's going on in the motion. And if you don't understand what's going on in the motion, then you might miss some of those other questions that are a little deeper. Okay? But just on these, that's great. Yeah. Boom, boom. I know the answer. I can move on to the next one. All right. What else we got, y'all? These are all great questions. You're going to see all of these tomorrow. No secret about what's on the exam. There are no secrets. I mean, there's some secrets, right? But no, there are no secrets. It's similar to past exams. Very similar. All right. What else? Oh yeah, for the approximations. Yeah. Is a kilogram 3 pounds? Yeah, it's like a little more, like 2.5 pounds or so. I don't know exactly what it is, but it's about 2.5 pounds. I always think like a person is about 70 to 80 kilograms. Um, a centimeter is about the width of your pinky. A meter is about 3 feet, a little more than 3 feet, approximately 3 feet. Um, a kilometer is what? zero point 0.6 miles? Is that right? Yeah, zero point 0.6 miles, about a half a mile. Again, on the approximations though, like the best way to practice those are just to practice them. Because you'll see the types of questions that I ask. Sometimes I give you some figure. Sometimes I give you a figure like the Rambit problem. Was that on your quiz? I think it was on your quiz, right? The Rambit. Yeah, like I'll give you a made up thing. I just want you to apply that measurement to some other, that measure to some measurement. '20 and fall '21. That probably is not on your exam. Let me take a look. Yeah, so number 20, we are not having vectors on this exam. So like on this one, you would stop at 16. There's a key on the exam page that has which questions are from which exam. It's at the top of the list, so no vectors. All right. I can put them on your exam if you want. All right, good. Is that it? No, Noah, what you got? Yeah, the same one. Okay, yeah, so you're going to have two-dimensional analysis. One of them I'm pretty sure is like this. We have three options, and then I'm pretty sure I gave you one like that. If you have one of these where I'm asking for the units of one of the variables, the first step is just to solve it for r. So for example, in this case, to solve it for r, I divide both sides by t. That would say that r is equal to a over vt. And then I put in the units for a, v, and t. These are a little trickier because you got fractions within the fraction. So I have meters per second squared, that's A. I have 1 over velocity, that is 1 over meters per second, or seconds per meter. I like to write it out like that, it'll make it easier. And then I have 1 over t, which is 1 over seconds. That cancels with that cancels with that, and I'm left with 1 over second squared. I'm pretty sure I gave you one like that, okay? I almost always do. I have a spreadsheet that has all the categories of the questions, and I usually just stick to the number of questions. So for example, as you're looking at this, you see that there are 2 estimation problems. Your exam also will likely have 2 estimation problems. Or there are 2-dimensional analysis problems. Yours also will likely have 2-dimensional analysis, and on and on. Owen? There are 8 free response, right? Or there are actually 3 total questions in free response, but with 8 parts, so it counts as 8 separate questions. And then there are 20 multiple choice. And each one is worth 100 divided by 28, which is roughly, 3 point something points. You can miss, well, if you miss 3, that's like an 89 point something, I think. Okay, miss it that. That's fine. Don't miss any. That's really what you do. Don't miss any. There will likely be a few perfect scores, but usually only have a few perfect scores. Though y'all really rocked the quiz. Was it an easy quiz? The average was like really high. What? Lots of practice. What? Yeah, right. I'll tell everybody that. Okay. Any other questions, y'all? sig figs. You will have to keep proper sig figs for the question, like this number 5, but the other questions will not be distinguished by the number of sig figs. I'm not testing you on sig figs on the other questions. Okay? Is that clear? Any other questions? All right, don't leave. Let me make sure that I got everybody before you go.